I'm from NUS, from the Department of Chemical and Biomolecular Engineering, but I'm also in the NUS Environment Research Institute, NERI, as you can see here. So the Environment Research Institute is an institute that hosts faculty members from various faculties and departments around the university. So we do a lot more multidisciplinary research there, especially on food waste. So that's what we're going to talk about today. And before I go into the presentation itself, I'd like to thank our funding agency, the most important, so National Research Foundation. And this program is funded under the CREATE umbrella, the Campus for Research Excellence and Technological Enterprise. So if you ever drive by the AYE past Clementi Road, you will see the a tall building with CREATE, the red CREATE on the top. So that's where our lab is and our office, and yeah, we have our research on waste there, although it doesn't smell like waste, so we're happy to show you around here if you want to come visit our lab there. I also like to thank my colleagues who contributed to this work that I'm going to talk about today. So in E2S2 CREATE, as Graham mentioned just now, we are a collaboration between Shanghai Jiao Tong University and NUS, so all of the faculty members from these two departments that took part in this program are listed here. And I want to thank in particular the program director, Professor Peng, and my colleagues there who worked on this project, Professor Bai Jin, and Professor Wang Ruzhu, and Professor Ge Tianshu. In NUS, I have a couple of colleagues who have been helping in the food waste project, Professor Wang Qihua and Professor Lo Kai-chi. And two others work on more of the modeling aspect of our project, which I'm not really going to talk about today, Professor Adam Meng and Professor Michelle Cardan. Of course, I can't miss out the people who really did the work, my research fellows and PhD students. So these include Dr. Zhang, Dr. Lim, Dr. Tian, Dr. Li, and Mr. Lim, among the many who have contributed. So they are the ones who are the experts. Just a short introduction into this program, E2S2 CREATE, Energy and Environmental Sustainability Solutions for Megacities. We are looking at how to solve coupled problems, as Graham mentioned. So why are these problems coupled? They're in two aspects. One is the coupling between Singapore and Shanghai, two different cities. And they're cities, they are not exactly the same. They are big cities, but Singapore, if you think is big, compared to Shanghai, Shanghai is 5 times the size for population compared to Singapore, and even in terms of land area, it is about 6-7 times the land area of Singapore. So Shanghai is much bigger, and it's also much more older and complex city. So if you couple the size and complexity between these two cities, if you want to find a solution to managing food waste in the two cities, then you need to do test bedding. You need to try out your solutions in Singapore and Shanghai to see if they work. But you can't rely on experiments or test beds all the time. You might want to develop a computational model of the system itself, and then try to see if we can extrapolate and interpolate within the findings that we have. So that's what we're looking at here in E2S2 CREATE. We do both experimental work, development of technology, and computational models to help city governments come up with solutions to manage two issues, waste and emerging contaminants. I'm not going to talk about the emerging contaminants part, so I'm going to focus on the waste management part for today, mainly focusing on food waste. But if you look at Singapore, this is a very rough statistics just to show that the trend of waste generation has increased from 2000 to 2014. This is not very new. I just wanted to show that upward trend. You can see the increase is almost 50-60% for total amount of waste generated. Although we do recycle a lot, which is the black line there, recycling has also increased correspondingly. But the amount that is sent to the incinerators to be disposed of is that gray line at the bottom. So that amount has also increased. But to go into the more detailed statistics, so this one is more fine-grained and more comprehensive. So from 2003 to 2018, you can see the total amount of waste is in the red line has increased significantly. And the different types of waste would include food waste, which is this blue line over here, increased from almost 550,000 tons to 700, 800,000 tons in the last 2 years. And then we have plastic waste, which also went up quite a lot. Ash and sludge, glass, textile, and leather, and among others. So this is not a comprehensive list. This is just a figure to show the increase in the amount of waste generated. If you really want to see the numbers, these are the numbers here for 2019. So in 2019, the total amount of waste generated is 7.6 million tons of waste, but 60% of it is recycled. So we recycle about 4.6 million tons, and about 3 million tons is disposed of in the incinerator or directly to the landfill in Semakau Island. So you look at food in particular, so the food would be almost 760,000 tons, only 17% of which is considered recycled. So recycled doesn't mean it's made into new food, but is used for other purposes like animal feed or made into other materials. But we still have about 630,000 tons of it being disposed. So as Andy mentioned, that's a lot of food waste that has to be disposed of. Compared to the others, there are good news though. You can see those waste that are on top of the list here. Those are the ones that can be recycled very well and has been recycled very well, more than 90%. So those are used mostly construction waste, metals, and slag. Those at the bottom here, plastic, food, ash, and sludge, these are those that are poorly recycled. So we can develop more technologies to manage these wastes and treat them. Then they would help to reduce the amount of ash that we send to Semakau Island and prevent it from being filled up. So you might know that the government has been saying our only landfill here in Singapore, Semakau Island, will be filled up by 2035. So what do we do after that? We have to come up with new solutions. To give you a bit more detail about the food waste, almost 800,000 tons in 2019, 2020. And consumer food waste comprises more than 60%. So consumer food waste would be those that we throw out from our households or from places like hawker centers, canteens, food courts, kitchens, hotels, where the consumers eat the food and or the kitchens that cook it, the food that are not fully utilized are disposed of. The rest, the other 40%, actually comes from the industry. So the food manufacturers themselves or the food processors. So as they convert the food into other forms, they throw out quite a large number of food waste. I want to highlight though, among these food wastes that are being disposed of, there are a lot of contamination in there. The contamination rate can be as high as 40, 60%. So things like plastic cans, cardboard, tissue paper. I'll show you some of these pictures afterwards. So the challenge is that these food waste, they are not all the same type. Whatever we throw out into the rubbish bin, the food waste, they're vegetables, they're meat, there are carbohydrates like rice or noodles. They're all mixed up together, and you have different types of cooking, Western, Chinese, Korean, and so on. So all types of cooking styles that have different ingredients. Maybe some are oily, some are spicy. So how do you treat them homogeneously or in one system? Well, of course, nobody likes to handle food waste because it is smelly, right? If you keep it for longer, it will decompose in the hot Singapore environment, attract flies and maggots, and could give you health issues. So these are the problems for managing food waste here in Singapore. There are methods to handle food waste, except that in Singapore, what we currently do is just like what we do with all of the other waste. We collect them, put them all together with the paper, plastic, and other types of waste, and send them to the 4 incineration plants located, 3 in Tuas, 1 in Sembawang, to be incinerated. So they are burned at high temperatures, and energy can be obtained from that, and you get a byproduct of ash. But if you think about it, incinerating food waste is not very efficient. Food waste has a lot of water in it. Sometimes you could even throw coffee or beer or other things into the food waste, right? So incinerating this basically means boiling water. It lowers the efficiency of incineration process and generates a lot of this ash. That's where the ash comes from, mostly. So we have a different technology called anaerobic digestion that has been considered to be used for treating food waste. Singapore is going to build one of these anaerobic digesters in the new incineration plant, the 6th incineration plant, or actually they call it Tuas Nexus. It's an incineration plant co-located with a food waste digester, which comprises the anaerobic digestion system that is co-digested with sewage sludge. So anaerobic digestion actually is more suitable because it is a biological process that can handle all the liquid, the water in it. And I don't want to go into the detail of the process, the biological process. If you do have any questions about that, I'll be happy to answer it. But the main point of this picture then is to say that, to show you that if you put in all these biological waste like food waste, yard waste, even paper, what you get out is the microbial community will eat all of these and produce a biogas that can be used to produce electricity. If you run it through a combustion engine, you can use the low value heat to get waste heat that can be used to heat up hot water or do humidification or air conditioning. And the byproduct from this process is a liquid we call a digestate, which can be used as fertilizer or can be further gasified to produce more power. So in this process, there are no waste at all. The production is this biogas that can be used as energy resource, and the digestate can be further used as a fertilizer resource. We then don't need to dispose of anything using anaerobic digestion. So we have built anaerobic digesters for other things, but even to build it in Singapore, you either have to locate it in Tuas, very far away, and then you have to go and collect all of the waste from kitchens, hawker centers, restaurants, and truck them out all the way there. Or alternatively, you can build small-scale compact digesters that you can place on site where you are generating all of these waste, food waste that you can see here. So our research is looking into this second option. Try to increase the efficiency of digestion so that you can put a small-scale digester safely and cleanly in the kitchens or the hawker centers, or the food courts around Singapore. So I show you these pictures of food waste, like I said, so you can get them from the kitchen or after when you're cooking, or from the table, which is what you don't fully eat up, then you throw it away. We can sort them out actually. But you can see even in these pictures, there are a lot of plastic bottles, cups, cardboard containers, plastic bags, even metal cans, right? So we have to sort this out because these are not food waste and they cannot be digested. So if you put them into a process, it doesn't really hurt the digestion, but it just won't be digested, and you'll maybe jam up your pumps and your tubes and cause mechanical problems. So we try to remove this by sorting them. So we need to build better sorters actually before we can treat the food waste. But we also analyze these food waste. Take a look at these, like they're like vegetables, right? Then you can see eggshells, you can see meat, you can see maybe you can't see the rice and noodles in there, but there are rice and noodles in there. So we try to characterize them to see what is in there, like how much carbon is there, hydrogen, oxygen, and so on. So we do the elemental analysis. We also characterize for the actual total solids, actually the solid amount that is left in there. So you can see the total solid that we measure is about 30%. That means the rest of it, the other 70%, is water. So there are a lot of water in food waste, that's for sure. And we also characterize for what we have here. This is the BMP, or the base methane potential. So how much methane you can generate from this food waste. So it's about 570 milliliters of methane per gram of these volatile solids. So volatile solids are the solid that can actually be converted into organic gas. Okay, and the last one is the actual heat amount you can get, the lower heating value of this methane that you produce. We compare it across with other regions around the world. All these references that we get are food waste from other countries. They are quite similar. Don't have to worry too much about the rest, but the general point is they are almost average out to be the same. Okay. So just to recap again, the food waste, whether you are getting it from the industry or from the consumer, they are of this same composition and the same amount of methane that you can get from it, the biogas. And they are mixed and non-homogeneous, contaminated with plastics, located all over the place, from homes, condos, to restaurants, hotels and food courts. So how do you collect all of them? And the amount that is being generated from each of these sites are very different. You know, a very small amount in our homes to very large amounts in malls or supermarkets. And then you want to treat it very quickly because you can't store it, otherwise it will decompose and smell. So if you do really want to know, like we do collect some numbers from where the food waste are being generated and how much. For example, this one here is the hawker center at East Coast, the first one. So East Coast Lagoon Food Village produces between 200 to 400 kilograms of food waste per day. So you ever go to East Coast Park and do a run there, and you go eat at the hawker center, you'll see how much food waste is generated. And there are other food courts around the country. They generate between 100 all the way to 1,000 kilograms. The biggest hawker center is Toa Payoh. They produce about 1,000 kilograms of food waste per day. And the catering companies, or even NUS itself. So NUS canteens produce this amount of food waste per day. And Resorts World, Sentosa, produces between 500 to 1,000 kilograms of food waste per day. Yeah, I listed down on the right-hand side the challenges with those food waste, if you really want to know. The second slide here shows the food waste from the industry. So bread makers, for example, 5 tons of return breads are being generated every day. That's a lot of bread waste. And if you talk about the airport supplier, almost 4 tons of waste because they prepare the meals that are being used in the airplanes. The food hub itself, or supermarket suppliers, the amount of food waste generated, quite a lot, from 1 ton to 20 tons. The poultry hub produces 20 tons of chicken bones, feathers, parts. They are considered food waste. So you just to show you the different types of food waste from the industry and from the consumers that you can find in Singapore. So we collected all of these data. But our goal is not to collect all of these and send them to a central facility to manage. We want to build small-scale systems to treat it on-site. So if you have a factory that is producing 20 tons of chicken waste, can we build a digester that can handle these 20 tons per day on-site? So it has to be small enough to fit that site. Land is very expensive in Singapore. So how do you build something like that? So we did it in a few steps that I'm going to show here. We have to collect the waste and sort them. So like I say, we have to remove the contaminants. This is manual. This was what we did at the start in one of the canteens in the university. So we did it like this because students are very good. If you ask the students to sort the waste, they will sort it. So you can see the food waste goes into one bin. the non-food waste, the tissues, the straws, the paper goes into the other bin. So they will do that diligently. If all Singaporeans did that, even in the hawker centers and food courts, it will make our waste management much more easy. Because you can see these food waste can be digested if you don't have these contaminants in there. Yeah. So the next step is to take the food waste and do the anaerobic digestion. So we have built different sizes of these digesters. You can see on the right here. So this is a digester, sort of just like a stir tank. And we have blender and the other parts in this system here, pumps and other things. So the food is fed into the grinder, pumped in to the digester and added with microbes. The microbes grow and feed on the food and produces a biogas. We actually can fit all of these into a 20-foot container. So on the left-hand side here, this 20-foot container houses the entire system, including the power generator and the biogas purification unit in the next two steps. So the biogas that is being produced after the microbes digest the food sometimes have other unwanted gases like hydrogen sulfide and water. So we will remove this so that the biogas, comprising then of mostly methane and carbon dioxide, can be used in a power generator. So we have this power generator here, just a simple gas engine really, off the shelf. We just buy it and run the biogas through this and try to recover the heat from the exhaust and use that to produce hot water. So this is then housed all inside this 20-foot container. You want to see a bigger picture, we actually put a solar panel on the roof to provide additional energy since it's out in the sun anyway. And you can see this container is mobile and it's not plugged in anywhere. So it's standalone and self-sufficient. It doesn't require electricity other than what is generating from the solar panel and from the biogas engine itself, and doesn't require water. All you need is to feed it with food waste. So you put it next to the canteen here in this Raffles Hall to treat the food waste from the canteen. So treatment capacity is between 50 to 200 kilograms of food waste per day. And if you put in this amount of food waste, you can generate up to 40 cubic meters of biogas, which is equivalent to 80 to 120 kilowatt hours of electricity. The liquid digestate that we get out, we use it as fertilizer. I'll show you some of those applications to grow vegetables later on. We get about 200 kilograms of it per day if we put in 200 kilograms of food waste, and we get this remaining some solids, small amount, about 2 to 3% of that. If the amount of this 80 to 100 kilowatt hours, if you want to look at how much energy that is, it can power about this amount of phones and iPads, or bikes, even PMDs. But it's not really a lot. You can probably power a house for a 4-room HDB for 3 days or 4 days, yeah, depending on aircon usage. So that's food waste. Don't expect to get a lot of energy from it. As I was saying, the liquid that you get out as the byproduct with this digestate that we say can be used as fertilizer, because if we characterize the liquid, we find that it has a lot of nitrates, phosphates, and sulfates. This NP and also K is potassium. These are very useful to grow vegetables. So for both the liquid and the solid, we characterize it for all the other compounds. We do not have any toxic heavy metals, so this arsenic, cadmium, lead, mercury, so they are non-detectable because they are from food anyway. So, but because they are from food, you digest it, they actually have a lot of these nutrients that can be used to grow vegetables. So we took the digestate as it is, untreated, or we try to kill off all the microbes before we use it, heating it up to 60 degrees or 121 degrees, and then apply it to grow vegetables. And we found that if you put in too much of this digestate at high heat, the vegetable doesn't grow as well. But if you use it untreated or use it at low concentrations, the vegetables grow very well. So some of these are actual the actual pictures of the Thailand that we grow. We actually grow a few different types of vegetables: xiao bai chai, kailan, and kangkong. In our nursery in the US, so we grow them, measure how much of the vegetables can be grown, and the chart here on the left shows that if you want to compare with chemical fertilizers, that's the leftmost bar here. It's a chemical fertilizer that has 15% of nitrogen, phosphorus, and potassium, NPK. That's our comparison. You can find that the comparable ones are what we call 80-20 and 80-40, which is the digestate that has been diluted to 20% or 40%. If you don't dilute this, that's 100%. It's actually not very good, like I said. The weight of the vegetables that you get at the end is less than half. But if you dilute this 4 to 5 times, you actually get comparable weight of the vegetables at the end as with a chemical fertilizer. So you can replace a chemical fertilizer directly. Or you can want to measure the chlorophyll content, so how green the vegetable is, so that the chlorophyll is the thing that produces the sugar or the food for the vegetables. So again, chemical fertilizer is on the left here, and then compared with our diluted digestate. The diluted digestate actually gives us much greener vegetables because it actually is quite rich in nitrogen, which contributes to the chlorophyll content. So if you like green vegetables, you can use our digestate. Just show you a video here. Yeah, so that was a video produced by the university to showcase our work. But if you do want to see the next generation of this system, you can go to the East Coast Lagoon Food Village. So this is the earlier photos of the system. Is now fully operational, and it's quite automated. You don't have to, it's not manual, but this one can handle up to 300-400 kilograms of food waste per day in these two containers, 20-foot containers here. And there's this automated loader here on the right-hand side, as you can see. Just need to wheel your 120-liter food waste bins, and it will automatically feed the food waste into the system. And it will produce biogas and electricity that we use to supply back to the hawker center. So just to again summarize the big picture of this system in here, the food waste then is fed into a sorter and blender first before it's being passed into a feeding tank and finally into the digester. The anaerobic digester is the main component, produces the biogas where you purify the gas and store it before you run it through a gas engine. The gas engine produces power for the hawker center, and also heat is recovered to heat up the digester. The liquid digestate is stored into a tank that IMechE actually will use to fertilize the plants and vegetables along East Coast, in East Coast Park itself. So this is a project funded by the National Environment Agency together with E2S2 and IMechE. So if you ever go by East Coast Park now, except that you can't eat at the hawker center now, you will see our system. I'll be happy to show you if you do want to go by. So the goal of these small scale compact on-site system should be that it should treat food waste on-site, but it must be clean and odor-free, because you don't want to have the smelly food waste where you are eating. That will be uncomfortable for everyone. So you need to make sure that the food waste doesn't emit the odor that will affect the restaurants or hawker centers. We also want it to be automated and safe, because we are storing a biogas and running a biogas engine. So you don't want it to explode. We have to meet the SCDF's certification. Of course, the things that it can produce is hot water, electricity, and heat, and generally it should be low maintenance. And based on our calculation, if you are going to treat 1 ton of food waste per day, from the savings from the disposal itself, 1 ton of food waste actually costs right now $97 to be sent to the incinerators. If you treat it on site, you can save $35,000 a year just from the disposal fee. In addition, this 1 ton will generate 73 megawatt hours of electricity. That is worth almost $17,000 by itself. So this system costs about less than $200,000, so the return on investment is about 3 to 5 years. So again, just to summarize this, what we are designing is a high-tech distributed food waste food waste handling system that can be put on site for treating food waste in a clean, compact, and odor-friendly way to generate heat and electricity from the waste. It's designed to be suitable for city centers and urban areas, not for rural or agricultural farms or where you have lost land area. Of course, we do need to sort out the contaminants like plastic, paper, metals, or other inorganics so that they can be separately treated or recycled. And the savings that comes from the transportation and waste disposal, and you can produce about 200 kilowatt hours of electricity per ton of food waste. So I will stop here for today, and want to thank again Graham and Andy and Kobe for the kind invitation to give this talk to all of you. And I'll be happy to answer any questions.